My name is Ned Huntley. I'm Director of Public Works. And I just want to start off with a little bit of history. This is our 7th year we've been working on projects with the Picker Engineering program out of Smith College. We've had some very interesting projects, sidewalk, street reconstruction, water quality projects. This year was a landfill project, as you can see on the screen. We asked them to look at evaluating renewable energy at the landfill, especially at closure coming up in 2012. So with that, I'd like to introduce Dave Letta, who's our landfill manager and environmental engineer with the Department of Public Works. We have Lindsay Holly and Darcy Dwyer, who will be doing the presentation tonight. So with that, I'll let them take off. Thank you.
I wanted to thank everybody for coming. Like Ned just said, I'm Lindsay Holly and this is Darcy Dwyer, and we're senior engineering students at Smith College. Over the past 8 months or so, we've been looking into the feasibility of implementing some kind of renewable energy system on the Northampton landfill. And specifically, we've been looking at solar, wind, and biomass crops as potentially feasible options for implementation on the Northampton landfill when it closes in about a year. Today, this presentation, we really just want to give an overview of all of the information that we've gathered in the past 8 months and present it to you, get some feedback, and let you know what the city's kind of thinking about doing in the future. Specifically, first we'll give you a general description of the landfill site before diving into the 3 renewable energy options that I just mentioned. We'll specifically be looking more at solar energy, which is, as I will talk to in a minute, one of the more feasible options for renewable energy at the landfill, and the benefits of producing solar energy in general and on the landfill. And then I will speak to how our project fits into the bigger scheme of what the Department of Public Works is looking to do in the next few years.
So to give you a little background about the landfill, many of you probably know that it's located on Glendale Road, and it's in a residential neighborhood, also surrounded by wooded area as a buffer. It is broken up into phases to allow for temporal closure, and so it started out with the original phase, and then as it expanded, they moved on to the first, second, third, and now they're finally finishing up the 4th phase, and as Ned said, it is scheduled to reach capacity next year. Next slide. So the landfill currently receives between 32,000 and 49,000 tons of solid waste every year. And it receives that waste from outside community, up to 16 surrounding communities in addition to the city of Northampton. And so this generates an income for the city of around, in the past it's been around $450,000. So with the closure of the landfill, the city will no longer be receiving this income. And so this is one of the reasons why the city has asked us to look into the possibility of generating renewable energy on the landfill site. So before we go into renewable energy, the landfill currently is generating, or has been in the past, generating energy through methane gas collection. And methane gas is a greenhouse gas that is 23 times as potent as carbon dioxide. It's generated through the decomposition of waste, and it is, however, not a renewable energy resource because it will only be, well, methane generation will reduce over time exponentially. And instead we will be looking at renewable energy sources. And so we've been asked to look at wind, solar, and biomass, and so Lindsay will begin discussing our research in wind and biomass.
So the first renewable energy that we looked at was wind power. And when you look into the feasibility of implementing wind on a particular site, there's 3 major factors that you want to look at. And those factors include the technological limitations of the wind turbine itself, the elevation, as well as the wind variability at the site. A wind turbine is generally characterized by a specific set of weather conditions that will allow it to produce the maximum amount of power. The rated capacity and rated wind speed refer to the conditions under which the wind turbine will produce that maximum power. The cut-in wind speed refers to the wind speed at which the wind turbine begins producing any power at all. And so in order for the site to be a feasible site for wind power, you need it to be at least above the cut-in wind speed, if not closer to the rated wind speed. The hub height refers to the elevation of the actual turbine blades from the ground. And so the hub height is this distance right here, all the way up to where the turbine blades are. And this hub height is important because as you increase in elevation, wind speed increases, and you're also getting a less variable wind as your altitude increases. Looking at data that was collected at the landfill site, we can see here, this is wind speeds over, average wind speeds over the course of a month, or of a year. And the red line represents a typical cut-in wind speed for commercial wind turbines. And what we can see is that even if we increase the elevation up to about 70 feet, we still aren't getting typical wind speeds above that cut-in wind speed that's necessary to begin producing electricity. And so we determined that wind speed really isn't a viable option at the landfill. However, to check ourselves, because we knew that Hull has a wind turbine installed at their landfill right now that's very productive, we really wanted to check and make sure that we weren't missing something. And what we found was that the wind speeds at Hull are about twice as high as they are in Northampton due to the fact that Hull is right on the coast. And again, we determined that wind probably isn't a viable option at the landfill. As a result, we turned to looking into biomass crops. And biomass refers to any plant crop or plant material that can be used to produce energy. And in the case of our project, we're looking into biomass that can be used to produce electricity. It's combusted similar to coal or natural gas is combusted to produce electricity. Again, we picked out several factors that would be key in determining whether or not biomass has potential at our landfill. And specifically, we were looking at different types of biomass and the climates that are necessary for them to grow properly. The soil depth and crop maintenance, so harvesting and tilling, different crop maintenance that goes into harvesting these types of biomass. After looking over a variety of common biomass crops, we found that willow and switchgrass were really two crops that were typical of this climate and could be productive in this Massachusetts type area. The benefit of using willow over switchgrass would be that it has a planting lifetime that's about twice as long as switchgrass, about 22 years. On the other hand, the benefit of using switchgrass over willow would be that you can harvest the switchgrass annually, every single year, rather than every few years as you can with willow. And then you can see from both of these that root depth for either plant is going to be somewhere around a foot, maybe a little bit less, a little bit more, but in general about a foot of topsoil at least is needed in order for the plants to grow. This image shows a cross-section of the capping process at the Northampton landfill. The gray area at the bottom is waste, and the red line shows that impermeable cap that will eventually be over the entire landfill. The blue and green layers above the cap are, the blue is the sand drainage layer and the green is topsoil, and both of these layers help to increase stormwater dispersion on the cap, and the soil helps to prevent erosion because there's a certain amount of vegetation that's allowed to be in that soil to prevent erosion of the sand drainage layer and of that topsoil, keep the cap protected. So what we found was really the only amount of root depth that we have is this 9 to 12 inches of topsoil that's at the top. And as I mentioned before, we're looking into needing at least about 12 inches of topsoil for root depth, plus what's needed for general harvesting and tilling. Moreover, if we look into that tilling and harvesting process, we can see that there's a significant amount of just general perturbation of the soil on the landfill that really is unnecessary, and In addition to that, if we were to plant biomass crops, they would most likely need to have pesticides or herbicides used on them, which really isn't a desirable quality, especially considering we're in a residential area. And as a result, we decided that biomass also really isn't a recommended renewable energy for the landfill. But Darcy will talk about solar energy, which looks a little bit more feasible for our site.
So, just to preface our discussion on solar energy, we started out similar to wind, looking at what kind of case studies there are out there, and there actually are several cases of renewable energy, or of photovoltaic arrays being implemented on landfills currently. So that being said, that kind of sets a precedent for our discussion with solar energy. And so, again, there were 3 factors that we looked into in determining the feasibility of solar energy. We looked at how much sun is there in the Pioneer Valley, what kind of shading is there at the landfill, and what would be the optimal tilt angle of the photovoltaic panels at the site. So first we looked at, like, if you think about implementing a solar array, Massachusetts isn't usually the first place you would put a solar array in the United States, in comparison to, let's say, New Mexico. However, when you compare the solar energy potential, which is mapped out here on both the United States and Germany, Massachusetts has substantially more solar energy potential than Germany, which is the world leader in solar energy production. So, moving on, after determining that there is potential for solar energy in Massachusetts, we looked into how much shading there was at the landfill. And we used these devices called the Solar Pathfinder, which project the surrounding shading on this chart here that will inform us of how much shading there is on a monthly basis. And so we used that data to create 3 contours that show 0% shading, which is this yellow region, and that region is pretty much the top of the landfill. And that makes sense because the top of the landfill is pretty much at the tree line. And then all the way up to less than 5% shading. So this pink region has a maximum of 5% shading annually. And so comparing that to one of the incentives that we were looking at, so we were looking at several incentives, but one of the incentives has a maximum shading of 20%. So when you compare 5% shading to that maximum, it's really negligible. So we determined that it would be feasible to implement a PV array on that 5% region, which was 19 acres. So moving on, we looked at what kind of panel would be appropriate for the landfill site. And so here you have 3 pictures. One is a fixed tilt PV array, a 1-axis tracking array, which tracks the sunrise and sunset, and a 2-axis tracking array, which additionally tracks the solar altitude that changes seasonally. So one of the main issues in tracking arrays is that there are moving parts which require maintenance and can break more easily. And because it's going to be on the landfill site, the Department of Public Works wants to have the least maintenance required for this project. And so that was one reason that we determined that a fixed tilt array would be most feasible. Additionally, the cost of a tracking array outweighs the energy generation. So moving on from there, we looked at what the optimal tilt angle would be. And so we optimized the energy generation throughout the entire year and determined that 35.7 degrees would be the optimal tilt angle, which is consistent with research that we've looked at. So given that design that I just talked about with a fixed tilt array on the less than 5% shading region, covering 19.1 acres, we determined that up to 4 megawatts could be generated, or a 4 megawatt system could be implemented, which would generate 6 million kilowatt hours of electricity, or of energy, which is the equivalent of how much energy 550 households consume annually. And so here you can see a picture of a zoomed in portion of our layout. And these green boxes each represent PV panels. The blue represents access pads to the gas wells. And these gas wells have a 15-foot radius. So that's not an actual gas well, that's the radius that would surround it.
So once we had determined that this was a feasible system design, we wanted to look into if we do implement this solar array and it does end up producing 4 megawatts of electricity, how are we actually getting some monetary benefit out of this? And what we found was that solar energy, as you know, produces electricity. And this electricity can be used several ways. One way is that you could sell this electricity to another individual or firm or potentially back to the utility company and become a power generator. And this is really not in the scope of our project and not necessarily something that the city wants to do. And as a result, we have 2 other options, both of which are feasible and desirable. One is to use some of that electricity that's produced on the landfill for on-site electricity needs, such as the recycling center that's at the landfill. The additional electricity that's produced by the solar array could also be used for net metering, which means that the additional electricity would be connected to the grid, go back to the utility company. However much energy we send back to the utility company, they will subtract that off of the total city's electricity bill at the end of the year. However, because we're implementing solar energy and not some other more traditional energy at the landfill, the solar energy provides a societal benefit. And that benefit could be, for example, that solar energy produces significantly less carbon dioxide and greenhouse gas emissions than using, say, coal or natural gas. And so the state recognizes that and formally recognizes it as a renewable energy certificate, or in our case, a solar renewable energy certificate. And what this certificate is basically a credit for producing energy from solar power rather than some other energy source that's going to produce these negative externalities. These certificates can then be sold to other individuals or firms, and particularly to the utility companies, either on the open market or through state auctions. So back to the bigger picture of our project, everything that we just told you today will be summed up in a report that will be presented to the Department of Public Works in about a week and a half. And all of that information will be used as a basis for determining whether or not the city wants to continue looking into solar energy as a potential option for implementation at the Northampton landfill. If they do decide to pursue solar energy at the landfill, the city would submit a request for proposal, which basically means they would ask companies from across the state and in the rest of the country even for to submit designs and plans for construction of some solar array. Again, using the information that we've provided them with, the city can then go through those proposals and determine whether they're actually feasible designs and whether the company has really taken into consideration everything that they've needed to. And from there, reevaluate whether or not they want to continue with this solar energy project. And with that, I'll thank you again for coming and open the floor to any questions. Yes?
Did your study extend to the money?
We are
Assuming that this is a project that is going to be done, what kind of money are we talking about?
So we're currently in the process of looking at it for specifically this project, but looking at the case studies of Greenfield and East Hampton, those projects, first of all, the agreement with a third party would be to purchase electricity at a reduced price. So in Greenfield, it was 1 cent per kilowatt hour, and that would equate to an energy savings of about $250,000 over the lifetime of the project.
Lifetime of the project or the year?
Pretty sure it was the lifetime of the project.
250,000?
Lifetime of the project doesn't really make that much sense, because
Right.
I assume the
Yeah.
project is going to last 25, 30 years?
And we're still in the process of doing
Okay.
financial analysis. Yes.
Let me respond to that. I have a 4.16 kilowatt solar array on my house. I calculate that it'll take 10 years to pay it off at the current cost of energy. Oil continues to go up, it'll be less than 10 years. If oil goes down, it'll be more. So I think that's very likely would apply to this situation as well. Now, I haven't looked at this in detail, but based on my experience, I think that's a reasonable estimate.
If the gentleman's asking about the cost of the system, I can offer that often these requests for proposals include outside financing, so the city itself doesn't have a large outlay of cash, and that eventually the city will either be given the system or they will have an option to purchase the system after the outside investors make their money back.
Do you have any ballpark of what a 4 megawatt array might cost? I mean, is this an investment of millions of dollars or hundreds of thousands or?
It would be in the millions, probably between $1 and $10 million.
And 25-year lifespan, is that, someone mentioned that?
Yes.
I didn't catch, is this proposal using all of the landfill land acreage?
It is not.
It is not.
You can go back to the.
I know it said 19 acres, but I didn't realize what that was in relation to.
The actual property of the landfill is located on 52 acres, and so this pink region represents 19.1 acres.
Okay, and why are we limiting it to just the 19.1 rather than using all 52 acres?
Because of shading. So this is the north-facing slope. So the sun usually comes in, rises and sets at a southern
angle, yeah.
angle. And so the north-facing slope would typically be shaded. for
Okay,
most-
so the 0% shading means there's a lot of shade, not that there's no shade.
The 0% shade means there's no shading.
So this is the north slope. The yellow represents pretty much the plateau. It's at a 5-degree angle, which isn't really that much, but it looks almost like a plateau at the top of the landfill. So the yellow region is the plateau, and this is the north-facing slope, and this is the south-facing slope. So as you can see, the pink, the less than 5% shading would include the south-facing slope.
Okay.
But because the sun comes in at a southern angle, the north-facing slope wouldn't
Okay,
have.
thank you.
As part of this acreage that would be having the panels on there, how much of that is part of the unlined landfill and how much is it part of the lined landfill?
That's a really good question. I'm not sure of the actual number, but the lined landfill ends somewhere in this area. So I would say that the majority of it is definitely on the unlined, or excuse me, on the lined portion of the landfill. And it's a consideration that we're putting in our report that if there is concern about putting additional weight on the unlined landfill, we could always shift our project a little bit smaller and keep it just on the lined portion.
Can I do a follow-up?
Sure.
Have you been working with Robert Newton in any capacity at Smith College? And he did a lot of work on the whole, like aquifer and the complications of that. I'm just curious if there was anything to look at, if there was the weight, how that could adversely affect, you know, the leachate getting into the aquifer.
Right, we did not talk to him. We looked a little bit into the weight issue, and in general, what we found was that it's really insignificant because it's spread over such a large area.
Could you go back to the flow chart and where it's generating, the solar energy is going to be then put back into the system at the end, if you keep going, right there. The net metering, could you explain that piece
Sure.
again?
So what happens is the additional electricity that the solar array produces the array is connected to the grid, and that electricity goes onto the grid. And the city itself at, City Hall, the different schools, is consuming electricity in these different locations.
Right.
And basically what happens is, however much electricity this array would send into the grid, it would be subtracted off of the city's total electricity consumption.
Okay, so it'll be subtracted from the city's electric bill for all of the city hall, the schools,
Right.
city, okay. And then the certificates again, could be sold. These are certificates that are in addition to the actual electricity?
Exactly,
That
yeah.
we are-
So what happens is, the state recognizes that solar energy is providing some additional benefit other than just the electricity that it produces.
Uh-huh.
And so, if we step back a little bit, the state also has another project that it's called the Renewable Portfolio Standard. I don't know if anyone has heard of that, but basically it is encouraging utilities to provide a certain amount of their electricity by renewable energies. And so it may request that utilities, or even require that utilities provide, say, 20% of their electricity from renewable energy sources. And so if the utility was to purchase some of these solar renewable energy certificates from the city, then they would in essence be providing that proportion of their required energy needs. Yes.
Do you have any sense, or were you able to gain any sense of how much energy the city buildings use?
I think maybe Ned Huntley would be better to answer that question.
Actually, Chris Mason would answer that, but he's not here tonight.
Going back to how much money this would bring to the city, I mentioned that case study, but I just realized I forgot to tell you how much energy Greenfield's landfill is estimated to produce, and that's half as much as this system. So it was a 2 megawatt system, as much as 2.5 megawatts, but I believe it was set at 2 megawatts in comparison to our 4 megawatt system, which would generate energy reduction of, or reduce the cost of energy by $250,000.
You said over the total lifespan? Doesn't seem very much at all. Am I missing something?
I mean, we're still in the process of.
No, I mean,
finalizing
just
that.
not knowing anything about anything, it doesn't seem over 25 years, that's not much at all. You mean totally, the city would make $250,000 basically, over 20 years?
In addition, the city has the Northampton Sustainability Plan, is that what it's called? Where the city has committed to reducing their carbon producing energy. And so this would also contribute to that effort as well.
As far as energy savings are concerned, a lot of it's determinant on what the utility rates do in the next 25 years. So sometimes it's hard to estimate how much the city will actually save until the rates will probably go up, especially if things happen like Vermont Yankee gets shut down. Businesses start to reduce their consumption of electricity. And also, the amount saved is determinant on the power purchase agreement that the city has with the owner of the facility.
So what's the reason for doing it if the city's only gonna make $25,000, or is that about it, for
10,000 a year.
10,000 a year? What's the point? Why not lease the land for a lot more than that and let somebody else do all the headaches? I don't know, it just seems kind of funny to me. I thought it
Lease
would,
the land to a company to generate energy, is that what you're saying?
to anybody.
I mean,
Play ping
so-
pong on, or to put an antenna on. We're making money now from some antenna.
I'm not sure if we explained it clearly, but so the city would be working with a third party that would lease the land. And,
Okay, I didn't get that.
sorry, yeah. So a third party would be leasing the land. They'd be receiving these renewable energy credits and selling the electricity that they generate to the city.
At a lower cost.
Yes.
So we get a lower cost for electricity and get a leasing fee.
a small leasing fee. But the benefit to that is that the city doesn't have the expertise or the manpower or the initial funds to provide for this project. And so that third party would be covering all of that, and including the maintenance of the project and the permitting fees, which would be a lot of money, up to probably $50,000.
Up to $50,000 in total?
I believe so, right?
Yeah, it can be at least $150 to, or excuse me, $50,000 to $100,000 in just permitting and interconnection with the grid, different fees and surveys that have to be done to begin the project. But that would be something that this third party would have to handle.
And the solar renewable energy certificates, you're saying, would go to the actual person who's running the program, and then they use those to sell to the open market. Those sound like probably the most valuable thing you've got right there.
Exactly, and part of our project, I think that's kind of a big portion of what our project is about, is putting together all of this information so that if the Department of Public Works goes through with this project, they know that these exist and how much they're actually worth. And so that when a third party comes in and proposes some amount of, yearly income that they're going to be providing the city with, they're going to know whether or not that's a reasonable amount of money or not. Yes.
It seems to me, first of all, is your project complete, or do you have one step further and that has to do with the finances? There is a piece missing from what I understand.
Yeah, the financing piece has been a little bit of a snag in our project. I think
Okay.
overall, we've kind of determined that the project isn't so much making a specific system recommendation, it's more of a feasibility analysis, and because of that, it's difficult to make specific cost and revenue calculations, because we're not recommending some specific system design that we can go out and pick, this is the photovoltaic panel that we're going to use, and this is the exact inverter that we're going to use. And like Darcy said, we've kind of been making broad estimates about things and looking at other cities that have been doing similar projects, try to get an idea of the income that they're getting from it. But yes, like you said, we're still working to kind of pull together that financial analysis to give a range of.
It's also difficult to gauge the incentives because the time period is generally, it doesn't extend out very long, and so it's hard to project what incentives will be out there when this project is implemented.
However, people are building solar panel arrays, and they are facing exactly the same problems as you're facing. I would consider that the project to be a little bit incomplete unless there was a financial section at the end, even if you have to make some assumptions, which, could be a little bit off the wall. Are you going to have a presentation at the end of the semester at your student union?
Yes, next Friday.
Oh, it doesn't give you too much time, does it? Okay, thank you.
Just to elaborate on that, I actually kind of agree with George. I think a key piece of information would be to know what the city's current electric bill is. The net metering clearly hinges on that. If we could, I doubt we could, but if we could, for example, use up the entire generation capacity of the solar arrays with the city's bill, we would get the highest possible return, is that right, on the electricity?
You're saying we could basically net everything out? Yeah.
Yeah, so that would be the best, and so that's, I would think, to put this whole thing in perspective, that's the number we need here.
Yeah, we've been in touch with Chris about this number, and I think he's in the process of getting it to us. We've asked for it. But to give you an idea, Amherst consumes I believe it's 10 million kilowatt hours. And so this project would generate a little more than half.
Oh, so there's a good chance we could use all of this in the net
Definitely,
metering scheme.
Definitely.
Yeah, the electricity produced by the solar array would almost certainly be enough. The electricity consumed by the city is almost certainly larger than the size of the solar array.
Perfect.
The city of Northampton, not the residents, you're talking about the municipal buildings.
Right.
Okay.
So that's ideal.
That is something that you could put in your report towards the end. It would help.
Could you say that again, that the city produces, or it uses more electricity in its buildings than could be covered by
Right.
this solar array?
Right.
But that's what we need to know, is like what percent of the total electric bill could be covered by this net metering?
Right.
I'm just curious, there are other, it's my understanding we have other solar arrays in the city, so I think an interesting thing too would just to be how much we're already perhaps saving on the buildings that we have them on. We do have them on some of the buildings, right? So I'm just curious about, like, it would just add, and then the potential for, and this doesn't have to be your project, but the potential of other buildings to have the solar arrays, would be nice to know that, but that's just a thought.
You may not be able to graduate with your class. You've got some.
Well, our professors in the audience agree, so.
I have another question though, and this may not be fully yours. I know you were looking mainly at the landfill site, but we also have some property that's next to the landfill, the Fedora property that currently is nothing's happening on. I'm just curious if that's a reasonable, and maybe it's a Ned Huntley question, but if that's a reasonable place to do something like the biomass, the switchgrass, or anything like that, because it's land that's just sitting there.
We'd actually just looked at the 52-acre parcel of the existing landfill itself, not the Phase 5 expansion area or the Fedora property as part of this project.
Further questions?
Well done.
Thank you very much.
And I just want to say this is a wonderful project that we've done again for the 7th year we've been doing this. This is concept level only that we're doing with preliminary feasibility, whether or not this can happen. Hopefully something can come out of this project, and we can look at something with the closure of the landfill in 2012, 2013, whether or not we can implement something out there to do this renewable energy project. Thank you all for coming. We appreciate your time.
Hopefully next time you visit Northampton in 10 years' time, you will see the fruition of your efforts.
Yeah.